Welcome to your deep dive. Today, we're going to be tackling AI and unsupervised learning, specifically in computer vision. You sent us some research on this new model called V-JEPA,
Yeah.
Video Joint Embedding Predictive Architecture.
It's a mouthful.
It is a mouthful, and it's making some waves.
Yeah, it's technically a pretty big challenge in the field. How can we get a machine to learn and understand the world? Video, but without any labels.
Without giving it instructions. Yeah, that's a tough one. I mean, we do it all the time.
Yeah.
How do we replicate that?
It's kind of like if you think about how we watch movies.
Right.
Even without subtitles or explanations, our brains are kind of predicting what will happen next.
Right.
VGP kind of tries to do the same thing.
Like you're watching a movie trailer.
Right.
And your brain just fills in the gaps.
Exactly.
Anticipating what's coming next.
Exactly. So it works by masking portions of a video.
Yeah.
And then predicting the visual features of those masked parts. Right. So it's kind of like filling in the blanks of a story based on the context you already have.
I see. Now, what's interesting is that most previous models tried to predict the pixels,
right,
like the actual dots that make up the image. V-JEPA is a different approach.
It focuses on those higher-level visual features rather than getting bogged down in the minutia of each pixel. And that makes it much more efficient computationally. It's like getting the gist of a story instead of memorizing every word.
So instead of recreating the image exactly, it's trying to understand the underlying meaning or concept.
Precisely. Like imagine you're describing a scene to somebody.
Yeah.
You wouldn't list every little detail.
Right.
You'd focus on the essential elements.
Yeah.
Right. Instead of saying brown and white canine with 4 legs, you'd just say dog.
Dog.
And that's what V-JEPA is doing with video. It's learning the language of visual concepts.
Okay, so by predicting these features, it's learning to understand motion, the relationships between objects, and even abstract concepts without getting bogged down in those details.
Precisely.
So how did they test this?
So they tested it on a variety of tasks. One was action recognition. Using this data set called Kinetics 400. And basically, the model had to watch a video. And identify what action was taking place.
Sounds challenging.
And they achieved 81.9% accuracy on Kinetics 400.
That's pretty good.
Yeah, and this is without any labeled data for this specific task. So it really highlights the power of unsupervised learning. And V-JEPA's ability to kind of learn these general concepts that can then be applied to new specific tasks.
So it learned to recognize these actions just by observing videos without actually being told?
Without explicit instructions, that's right.
That's impressive.
Yeah, it's a big step towards AI that can learn in a more human-like way.
Now, they also tested V-JEPA on something called motion classification. Using a data set called something V2.
Something V2.
What's special about this data set?
It focuses on more nuanced movements and interactions between objects. So it's not enough to just recognize the objects themselves. You need to understand how they're moving and interacting with each other over time. So it really tests a model's understanding of what we call the temporal aspect of video.
So like understanding the difference between pouring water into a glass versus spilling water on the table.
Right.
Even if the objects involved are the same.
That's a great way to put it. And on something V2, it achieved an accuracy of 72.2%.
Wow.
Which is pretty remarkable considering this is all about very subtle movements that even humans can struggle with.
Yeah, for sure. The fact that it outperformed other models that were designed specifically for action recognition really shows how effective this feature prediction approach is for understanding motion. The dynamics of how things change over time.
Exactly.
So to train a model like this, you need massive amounts of data, right?
You need tons of data.
Yeah.
Absolutely. And the researchers used a data set called Video Mix 2M, which contains 2 million videos.
2 million videos? Where did they find all these videos?
They combined a bunch of different sources. So they use How to 100M, which has a lot of instructional videos and DIY projects and tutorials. Kinetics, which we've already talked about. And something V2.
So it's like V-JEPA got a binge watch.
Right.
This massive library
of
videos covering everything. So everyday actions to really intricate object interactions.
Yep.
I imagine that played a crucial role in its success.
The sheer size and diversity of VideoMix 2M exposed V-JEPA to this huge range of visual experiences, and that allowed it to learn a more robust and generalized understanding of the world.
Now let's pause here for a second and connect this back to our listener.
Okay.
Why should you care about a model that can predict features in videos? It seems pretty abstract.
It's about more than just video, though.
Okay.
This research could really change how we approach machine learning in a very fundamental way.
Okay.
Imagine, robots that can learn new skills just by watching you.
Oh, wow.
Cars that are much safer because they can anticipate what other drivers and pedestrians are going to do.
Right.
Personalized entertainment systems.
Right.
That can predict what you want to watch.
Right.
The applications are huge.
It seems like we've only scratched the surface of what this technology can do.
Absolutely.
And to think, V-JEPA wasn't even designed to analyze static images.
That's right.
What happened when they decided to test it on ImageNet, which is a benchmark data set for image classification?
So that was a real surprise.
Yeah.
V-JEPA, even though it was trained on video, performed really well on ImageNet.
Yeah.
It achieved an accuracy of 77.9%, which was on par or even better than some models that were specifically designed for image classification.
That's like training someone to be a chef and discovering they're also a world-class painter. What does this tell us about V-JEPA and how it learns?
Well, it suggests that learning from video might actually be a better way to train models. That can then be applied to both video and static images.
Makes sense.
Think about it. Videos contain so much more information than a single image.
Right.
There's motion. There's a sequence of events. There's a story unfolding.
Yeah.
So if a model can learn to understand all of that, it makes sense that it would also have a strong grasp of the individual images within that video.
It's like learning a language by immersing yourself in a foreign country instead of just memorizing vocabulary lists.
Exactly.
You get a much richer understanding.
You get the context, right? And this has huge implications for the development of more versatile and robust AI systems.
So to recap, we've got this model V-JEPA that learns by watching videos, predicting what comes next. It's really good at understanding motion and actions. And it can even apply what it's learned to analyze static images. That's already pretty incredible. But you mentioned something earlier that I want to come back to. You said that V-JEPA seems to be developing a kind of common sense about the world. What does that even mean in the context of AI?
Think about the things that we just take for granted when we watch a video.
Yeah.
We know that objects don't just disappear randomly.
Right.
They persist over time, even if they're temporarily hidden from view. We understand that things fall down, not up, and we can often anticipate why someone is doing something.
So we're not just seeing what's happening, we're understanding why it's happening.
Exactly.
Based on our knowledge of how the world works.
That's exactly it. And what's remarkable is that V-JEPA seems to be picking up on these concepts as well. It's not just learning patterns, it's starting to reason about the world in a way that's similar to how we do.
It's still early days.
It is.
But if we can develop AI systems that have this kind of common sense, it would be a huge breakthrough.
Oh, yeah.
Robots could navigate complex environments more easily, self-driving cars would be safer, and virtual assistants could finally understand what we really mean.
The possibilities are really quite exciting, and V-JEPA is just one example of the incredible progress being made in the field of unsupervised learning.
Let's talk more about that. Why is unsupervised learning such a big deal?
It represents a fundamental shift in how we approach AI. Instead of feeding the machine tons of labeled data and telling it exactly what to learn, we let it learn directly from raw, unlabeled data. This is much closer to how humans learn.
So instead of giving it a textbook, we're giving it a playground.
Exactly.
And letting it figure things out on its own.
That's a great analogy. And just like kids learn better through play and exploration, unsupervised learning has the potential to create AI systems that are more adaptable, intuitive, and ultimately intelligent.
But there must be challenges too, right? If you're not telling the model what to learn, how do you even know if it's learning anything useful?
That's one of the biggest hurdles in unsupervised learning. Unlike supervised learning, where you can measure accuracy against a set of labels, it's much harder to evaluate progress.
It's like judging a piece of art.
Exactly.
There's no right or wrong answer.
So researchers have to come up with creative ways to assess these models.
Right.
Often by testing them on downstream tasks that require some level of intelligence.
And that's where V-JEPA's performance on tasks like action recognition and motion classification really stands out.
Right.
It's demonstrating that this model is learning something meaningful about the world, even though it hasn't been explicitly told what to learn.
It's a testament to the power of this approach. Now, you might be wondering how all of this works under the hood.
Actually, yes. It seems almost magical.
Yeah.
Can you break down how V-JEPA is structured and how it's trained?
Sure. At its heart, it's a type of neural network called a vision transformer.
Okay.
These networks are especially good at processing sequential data like video frames.
So it's like feeding the model a flipbook one page at a time.
Right.
And it's learning to understand the story as it unfolds.
That's a good visualization. Now, remember how we talked about V-JEPA predicting visual features instead of pixels?
Right.
Well, to do that, it uses an encoder, which takes those raw video frames and transforms them into a set of abstract features that represent the essence of what's happening.
Okay.
It's like translating the visual information into a more compact and meaningful code.
So the encoder is like a chef who takes raw ingredients and transforms them into a delicious dish.
I like that analogy. And then we have the predictor.
Okay.
Which is really the heart of V-JEPA's learning process. It takes those features from the encoder and tries to predict the features of the masked portions of the video.
It's like trying to guess what's in a wrapped gift by shaking it and feeling its shape.
Exactly. The training process involves showing the model thousands of videos, masking out random portions, and having it predict the features of those masked parts. Through trial and error, it gets better and better at this prediction task.
So it's learning by doing, essentially, the more it sees, the more it learns about the world, and the more accurate its predictions become.
That's the essence of it. And what's fascinating is that this simple process of prediction leads to a surprisingly deep and nuanced understanding of the visual world.
It really makes you wonder about the nature of learning itself. If a machine can learn so much just by observing and predicting, are we humans doing something similar on a subconscious level?
That's a profound question, and it's one that researchers are actively exploring. The study of AI is not just about building smarter machines, it's also about gaining a deeper understanding of our own intelligence.
We've talked a lot about the potential benefits of V-JEPA and unsupervised learning.
Right.
But with any powerful technology, there are also potential risks and ethical considerations.
You're absolutely right. As this technology continues to advance, we need to think carefully about its impact on society and ensure that it's developed and used responsibly.
Let's shift gears and explore some of these concerns in more detail. One that often comes up with AI is the potential for job displacement. As AI systems become more capable, are they going to put people out of work?
It's a valid concern. We've seen it happen before, with new technologies.
Yeah.
But it's also an opportunity to rethink our relationship with work.
Right.
History has shown us that technological advancements often lead to the creation of new jobs and industries that we couldn't have even imagined before. So instead of fearing job displacement, maybe we should focus on adapting and evolving alongside AI.
Yeah.
Perhaps AI can free us from these tedious tasks and allow us to focus on more creative and fulfilling pursuits.
It's like the invention of the automobile didn't eliminate the need for transportation.
Right.
It just transformed it.
Exactly. And just as we learn to drive cars, we can learn to work alongside AI.
Right.
It's all about embracing the possibilities and preparing for the future. But to do that effectively, we need to address some key challenges.
Like making sure that these systems are developed responsibly.
Absolutely.
And don't perpetuate existing biases.
AI models are trained on data
Right.
created by humans.
Yeah.
And that data can reflect the biases
Of course.
that exist in our society.
Right.
If we're not careful, we could end up with AI systems that reinforce those biases, leading to unfair or discriminatory outcomes.
So it's not just about the technology itself, it's about how we use it.
It's about how we use it. Yeah.
We need to be mindful of the potential consequences and ensure that AI is used for good.
I completely agree. The development and deployment of AI needs to be guided by ethical principles and a deep understanding of the potential societal impacts.
It's like giving someone a powerful tool.
Right.
It can be used to build something amazing or it can be used to cause harm.
Exactly.
It all depends on the intentions and actions of the person using it.
That's a great analogy.
Yeah.
We have a responsibility to shape the development of AI in a way that benefits humanity as a whole.
We've covered a lot of ground in this deep dive.
We have.
We explored the technical details of V-JEPA, its impressive capabilities, and its potential applications across numerous fields. We also delved into that broader context of unsupervised learning and touched on some of those ethical considerations surrounding this technology.
Yes.
But I want to end by circling back to something you said earlier.
Okay.
That really struck me, the idea that studying AI can help us understand our own intelligence better.
Yes, it's so fascinating, isn't it? If V-JEPA can learn so much about the world just by watching these videos, it makes you wonder if our brains are doing something similar, subconsciously. Maybe we're all running our own internal prediction models, constantly trying to anticipate what will happen next.
It's a mind-blowing thought. Are we all, in a sense, walking, talking VJPAs?
It's a possibility worth exploring. It highlights the interconnectedness of AI and neuroscience. As we build these more sophisticated machines, we're gaining new insights into the workings of our own minds.
It's a journey of discovery.
It is.
That's only just beginning, and it's one that I, for one, am incredibly excited to be a part of.
Me too. Who knows what breakthroughs await us in the years to come? One thing is for sure, the future of AI is full of potential, and it's up to us to shape it in a way that benefits all of humanity.
Well, thanks for taking this deep dive with us today. We hope you found it insightful and thought-provoking. Until next time, keep exploring, keep learning, and keep asking questions.